Hi everyone, this lesson is for Algebra 2 honors students. This is chapter 6, graphing logarithms. So let's get started. We are starting off with just a warm-up graph of an exponential equation, y equals 2 to the x power. So graphing this by hand, what I would suggest is just make a table. And we are going to plot points for x and y. So plotting points for x and y, I like to plot the points 0 and 1 all the time, every time, no matter what. But just 2 points isn't really going to satisfy, as many points as we want. So I might pick some values on the opposite side, on the negative side. So like -2 and -1. Also might choose 2. And so plotting these points, we're going to plug in 0. And so 2 to the 0 power, which is 1. And then I'm going to plot 2 to the 1 power, which is 2. I'm going to plot 2 to the -2 power, which is 1 over 2 to the positive, which is 1/4. So -2 is at 1/4. 2 to the -1 power is 1 over 2 to the positive 1, which is 1/2. And 2 to the second power is 4. So plotting these points on our little graph for this exponential, and what you should be thinking of is exponentials go up. They're going to increase, and because they're exponential, they're actually going to increase rather quickly. So we're going to start at 0, 1. So put a point there. We have one at 1, 2. We have a point at -2. 1/4, and then we have a point at -1, 1/2, and I have a point at 2, 4. So where is that? 1, 2, 3, 4. And so what's happening here is that this looks like my graph is going to get really, really close, and I can double check, like make a point, say -5, right? So that'd be 2 to the -5th power, which is 1 over 32. And what this is telling me is down here on my graph, down here, right? As my graph gets closer and closer to infinity, it's going to get closer and closer to 0, but it's never going to touch. And what that means is that we have an asymptote. And we have an asymptote right here at y equals 0. So that's an asymptote. And so you would say, okay, well, that means that my graph is going to get very, very close to that, but never touch. Therefore, that's what it is for that. Now, because we're doing this little review of exponentials, what I want you to remember, too, is that you also can think of as an inverse, right? Remember the inverse? Inverse is where we take x and y and we flip the values. So if I wanted to find the inverse of this exponential graph right here, I would actually reflect this. It's a reflection across my y equals x axis. But at the same time as it being a reflection across the x equals y axis, this is y equals x right here, okay? At the same time of it being a reflection across that, as I was flipping over a page. But I'm also going to take these points and I'm going to flip-flop them, okay? So in doing that, I want you to see, we're going to say then my points are going to be 1, 0, 2, 1. Then I have 1/4, -2. And I have 4, 2, right? So think about this. 1, 0 is here. 2, 1 is here. 1/4, -2 is here, right? 4, 2 here. So what happened as I'm flipping my graph across this axis like this, okay? Then what that's doing is that's giving me not only my inverse of my exponential function, but when you think about what we've been doing with our chapter, the inverse of an exponential function is a logarithm. So now let's think about what would that look like if I rewrote this as a log, right? Base to across the equal sign. Remember base? So this would be like log base 2, base to across the equal sign. That would mean x would be over here, right? and 2 to the x power is equal to my argument, or y. So what we're doing here, and then if we were to, right, find its inverse, switch x and y, right, we're going to be finding the inverses of each other. So this is what we get, is when we find the inverse of our log equation, is an exponential. So our learning targets today are discover graphs of logs and exponential functions, be able to graph these and their inverses. We're also going to be translating these vertically, horizontally. We're going to shrink them, maybe stretch them, and also definitely reflecting. So we're going to start off with a log base 10 of x. So when you think of log base 10 of x, you're thinking base to cross equal sign. You're thinking 10 to the y power equals x. Okay, that's what I'm thinking. And what I'm also thinking in my head is that the inverse of this is going to be 10 to the x power equals y. And this is my exponential, right? So graph this on Desmos, and you should get a graph going out right arm up like that and left arm straight down. While you're doing that, I'm going to be talking to you because I want you to understand, if I were to plot these points for 10 to the x power, so 10 to the x power equals y, and I'm going to plot for x and y. For this value, I'm going to plot for x, right? So I'm going to go 0 and 1. Plugging in 0, 10 to the 0 power is 1. 10 to the 1 power is 10. And if I were graphing this, right, I would go 0, 1. This is my exponential. This is what that is. It's an exponential equation because x is my variable, and that's my power. 0, 1, and then 1, 10. So 1, 10. Way up here. So this graph actually looks like this, and this is my exponential graph, okay? 0, 1. And now, if I were to take its inverse, right, its inverse, which is this right here, okay, think about that. If I were going to make that inverse, I would take these values and I'd flip them, and I'd get 1, 0, and I would get, so I'd get 1, 0, because I'm taking these points and flipping them, and I would get 10, 1. So that's way over here, 10 up 1. And what that's done is it's looking like this. All right. So graphing y equals log of x in Desmos gives you this graph right here. Y equals log base 10 of x, because base 10, log base 10 is 10 to the x. That's my inverse of my exponential. And you should recognize that you have an asymptote, or not an asymptote, but it's a reflection across y equals x. We have asymptotes. The asymptotes for a log is this one right here. And the asymptote for a log is x equals 0. While the asymptote for a exponential equation is y is equal to 0. And that's my asymptote. Okay? All right, here we go. This is my exponential. This is my log. These are taking the values and flipping them across. Note you also, on this, if this is 10, you can go 10 to the y power, right? Base to cross equal sign. So 10 to the y power equals x. And you don't have to graph the exponential equation first, right? And then flip it across the y equals x axis, or take the inverse. A lot of people will always graph the exponent, the exponential equation first, and then second step would be to take the inverse, all right? So you absolutely can do that to solve and graph. That being said, you don't have to, in a lot of cases, what you can do, you're going to plot for x and y, but if y is up here, I'm going to plug in to y first. So I would plug in 0 and 1. So I would go 10 to the 0 power is 1, 1 goes here. And then I would go 10 to the 1 power is 10, 10 goes here. And then that's my 1, 0, and then my 10, 1. So you can just graph this by, changing the way you're writing it and then plotting points for x and y. You could do that first. The next question is for ln of x, and the inverse function for that. remember, ln of x is actually log base e, right, of x equals y. So think about e to the y power is equal to x. And if I were plotting points for this value here, right, for x and y, again, because y is up there in the exponent's place, I would graph for that point. I would plot for that value. So 0 and 1. So e to the 0 power, anything to 0 power is 1. But then e to the first power is e, right? And e is actually 2.718. So 2.718, comma 1. And so if I were to plot these 2 points here, right, for this, for this value, I would graph this, and I would have 1, 0, and then I would have 2.7181. And so this graph right here, this graph is my ln graph. So this goes down. ln is very similar to log base 10, but it's not exactly the same for sure. This is my ln of x graph for y. And then I still have an asymptote going straight up like this. But for this one, so remember, this is 1, 0, and this would be 2.718, 1. And so what that would do there is, okay, and then if I want to find the inverse of that, right, the inverse of this right here, which is my ln of x, so the inverse of ln of x is y equals e to the x power. And for that graph, right, again, we would plot for x and y, but because x is my exponent, I'm going to plug in for x. And so that I would plug in 0 and 1. So e to the 0 power is 1, and e to the 1 power is 2.718. And so graphing this would give me 0, 1, and then over 1, 2.718. And again, this is exponential, right? Remember, anything that has a variable x as my exponent or my power is an exponential equation. And if the y is up there, that means that that's your inverse. And so what's happening here is, again, if you were to reflect this across the y equals x axis, right, you would get 1, 0, and then you would also get 2.718, 1. And this graph would look like this. And so, like I said, a lot of people will graph the exponential equation first and flip your x and your y, and or you can transfer it into a way that you can plug in some points. And so this is what we already did, which was our 0, 1, remember this, and then this is our exponential equation that looks like this. Now, this is log of 2 to the x power. And so remember the points, we did this in our warm-up, x and y, 0 and 1. So I've got 0 and then 2, 1, 2. So 1, 2, like that. So if this is 1, 2, and this value is 0, 1, the inverse of that, which is log base 2, because this is a base 2, so 2 to the y power equals x. I can just plot values for y first. So you just plot for y first, so 0 and 1. And then what values you get for 2 to the 0 power is 1, 2 to the 1 power is 2. So we've got 1, 0, and then we've got 2, 1. And again, this is my log equation, which is the inverse of the exponential equation, which is 2 to the x, and this is log base 2. The other one we did with the log, and we did 10 to the x, that was base 10, where this is base 2. So if you're on Desmos, what I'd like you to do is to graph all these parent functions and sort of see, especially ln of x and log of x, because what those values are doing is they're going to show you that they're not exactly, the same. They're slightly different, because when you think about log base 10 of x and ln of x, right? ln of x is at 1, 0, and also at 2.7181, so about here. So this graph does this, right? And then the other one, and it's a little bit rounder. So I'm going to redraw that part. It's a little bit rounder. And so this one here, more full, right? Because what's happening with a log base 10 is you still have 1, 0, And yes, you still have an asymptote that goes down on this axis. However, if you go think about this, this is over here at 10, 1, which is here. This graph for a log base 10 is actually going to go that way. So it's a little bit closer to the x-axis, as this being my ln of x, and this is my log of x, base 10. So we have transformations, and what's happening with this is we always recommend that you graph the parent first. So you can draw the parent exponential, meaning you can change everything to exponential and then take the inverse. Or you can graph it depending on how difficult, what the difficulty level is. But each of these has different things. Like the number in front of this value here, the C value, that's a vertical stretch. If C is negative or less than 0, out front, meaning if you have y equals a negative sign out in front of the log or the natural log, this value here, that negative sign, is a reflection across the x-axis, okay? Always the x-axis. But inside, if you had a negative parenthesis, like, so if you had, let's say, negative x here, right? This value here, that's a reflection across the y-axis, okay? Additionally, plus or minus moves your graph up and down. And then this value in here, like this, if you had, let's say, log of x minus 2 equals y, that's a graph that moves your graph to the right or to the left. That's what that does. And so, again, reflections, so if it's a little bit small, so reflections here, like this says negative x here, that reflects it across the y-axis. So if you can see that negative sign inside the parenthesis, right? If that negative sign is inside the parenthesis, that's a reflection across the y-axis. If the reflection is out front, so if I had y equals negative log of x, that's a reflection. So if I have log of x is here, that's my parent function. If the negative sign is out front, that's a reflection across the x-axis, which then, this being my x-axis here, then all these points would go the opposite way. So it'd be like that. It could be across the x-axis, okay? A vertical shift actually takes my graph and moves it up or down. So if I was talking about this graph here that I drew with this, okay, not that one. If I was talking about this graph right here, let's say I drew this, and I was saying that I had a vertical shift of 2, that's going to move everything up 2 units, okay, just like that. Whereas if the horizontal shift, it's going to take your graph, wherever that is, and move it to the left or to the right. So vertical shifts go up and down, horizontal shifts go left and right. So this is what we were talking about, reflection across the y-axis. This line here being the y-axis here. So if that was that way, you would always, hold on. So with these problems here, not only are you reflecting across an axis, but you're also creating a shift. So you're doing 2 things at the same time. And additionally, you can also have maybe a horizontal shift where you're going left and right, and you're also moving the graph up. So see how you have this x plus a, that's moving your graph left and right. The plus b, this value here, is the vertical shift. That's the vertical part of it, the b. So that's going to move it up or down, and this part here, whether it's plus or minus, is going to move it left or right. So if it's a plus a, you're going to the left. If it's a minus a, you're going to the right, which is in the positive. So it's like the opposite of whatever way you're thinking you're going. So like on this problem here, y minus 8 and then minus 3, this graph would go right 8 units, okay? So you would go 8 over to the right, and then the minus 3 would then take the graph down. So this graph that we started right here, which looks like it was a log base 10, what that would do is it first would go 8 over to the right, or that way, 8, and then down 3. And so that's how that happens. You go left and right, and then also vertical. So we're going to start off with this value here. It's an exponential equation. It's easier, I think, to plot points when you can, especially when we have all these shifts. So what you want to do is recognize what's happening. So what's happening in this exponential graph here is this. The first, that's a reflection across the x-axis. So that's the first thing that you're doing. Always do reflections first. This is a vertical shift, and that's going to move my graph up or down too. And then this value here, where it's with my exponent, that's going to take my value and it's going to move it to the left 1. So if you start off with the parent function, which is y equals 3 to the x power, that's it. That's the base function. Okay, and we know that that's a log base 3 also, right? If I wanted to do the inverse, which I don't, but I'm just saying that's what that is. You would plot 2 points. I would just start plotting 2 points. We have 0 and 1. And by plotting these 2 points, if I plot, excuse me, not like that. This is x and y. So if I take x and y and I plot for x and y, I plot 0 and 1. So this is going to be 3 to the 0 power, which is 1. And then I've got 3 to the 1 power, which is 3. So right away, I'm going to graph these 2 points, and you need to really keep track. So there's 0, 1, and then you have 1, 1, 2, 3. So 1, 3. All right, and you know your graph is doing this. That's what you're doing. So the first thing we're going to do is we're going to reflect it across the x-axis. So in doing that, this 0, 1 is now 0, negative 1. And this 1, 1, 2, 3, this 1, 3, right, is now going to be 1, 1, 2, 3, negative 3. So now I'm at 1, comma, negative 3. Because a reflection across the x-axis only takes, if you have x, y, it takes the opposite of the y. That's a reflection across the x-axis. All right, so right now we have this happening. So we have this reflection, okay? So now this plus 1 moves my graph to the left 1. So now I'm at negative 1, negative 1. And I'm at, and this is moving it to the left, I'm at 0, negative 3. So, right, this graph moved to the left that many. So I'm going to lose that graph because that's not very good. And I'm going to redraw that real quick. And so now we've moved it. So now it looks like this. All right. All right. And so that moved from this position here, which is way better over here. Okay. Now we are going to add 2. So wherever I'm at, my graph, I'm going to go up 2. And so now this point, which is at negative 1, negative 1, is going to go up 2. So this new point up 2 is here, which is at negative 1, 1. And my new point here is going to be, because I'm going up 2, 1, 2, which is at 0, 1. And so these are my new critical points that I've graphed. And there you go. That's my new graph. And so this right here, that first graph, I recommend that you try using like a dotted line for a parent graph or a different color so that you can actually see what the final graph looks like. So this is our graph. We've shown transformations. I wouldn't necessarily lose this line right here. I would just maybe start dotting values that as we go. And this is just the graph on Desmos. Same thing. So you're going to check a lot of your graphs on Desmos as you go, but that's how you plot it step by step. So for this problem here, we're going to list the transformations for this. Notice this is a base 2, so that's a log base 2 if you were looking for the inverse. This value here is a reflection across the y-axis, and this is taking my graph and moving it down 5 units. So we're going to start our graph with our 2 points that we usually use, And our 2 points for our parent graph would be y equals 2 to the x power. And then we would go x and then y. I'm going to plug in, because x is my variable up here, 0 and 1 here. So 2 to the 0 power is 1. And 2 to the 1 power is 2. So we have 0, 1. And then we have 1, 2. And so this is my exponential. I'm going to dot it. It looks like this. Okay. And it's going to go up like that. All right, so this now reflects it across the y-axis. So that would mean that my new graph is now going to look like this, right? And then this point that I had here at 0, 1 is still 0, 1. But this point at 2, 1, reflecting across the y-axis, is now negative 1, 2. And then we have 0, 1. This value here, plus 4, moves my graph to the negative 4 direction. So everything is moved to the left 4. So 1, 2, 3, 4. New point here. And this point here is now going to go 1, 2, 3, 4 over this way. And so my graph is now going to do this, like that. Okay? I still have an asymptote right here, meaning my graph's going to get very close to that but never touch. So here we are with these 2 points here. And now, lastly, I'm going to drop it down 5 units. So I'm going to go down 1, 2, 3, 4, 5 here. And I'm going to drop this down 1, 2, 3, 4, 5 here. And so what my final graph is going to look like is something like this. And keep in mind that as my graph dropped down 5 units, so did the asymptote. And so, do I have an asymptote? I don't. Let me make the asymptote. So if I had my asymptote that went right there, that's also going to drop down 5 units. So 1, 2, 3, 4, 5. So remember that when you're drawing your graph, that this line here is going to get super close to that, but again, never touch that. It's just going to get very close, but not touch. So there's my graph. Keep in mind that your asymptote moves with you, right? Okay. This is an exponential graph, but instead of this being going up to the right, if you notice, this is 1/3, which is actually y equals 3 to the negative 1, which is a decrease. So that's like going down like this. Another way of graphing these points, yes, you can graph 0, 0, 1 over and over and over again. But another option as well is to take these values that you have here, and this is going to be to the x minus 2, and then minus 4. So we kind of get the gist of what's happening with an exponential. An exponential positive is going to go up to the right this way. An exponential negative is going to go down this way. So just think about what's going to happen if I then move it 2 to the right. So now it's going to go this way, right? And then down 4 will go this way. That's what's happening. So we kind of get the idea of where that graph is going to go. The parent function, just a note, is y equals 3 to the negative x power, right? Because the negative 1. And if I were to graph these 2 points for x and y, I get 0 and 1. And at 3 to the 0 power is still 1. But 3 to the negative 1 power is 1/3. So we have 0, 1 here. And then we have 1, 1/3. And that should give you an idea. I'm not going up. It's coming down. So it's looking like this, right? And then as you're doing this right here, you're going to go right 2 units. So you're going to go to the right 2. So 1, 2, and then this will go over 2. As you're doing that, going to the right 2, and then down 4, let's say you chose not to, move your points with you. You can definitely plot points into this equation right here. Not a problem. You just plot your values in here, and then you get your numbers. And that's going to actually give you the final graph as well. So let's just plot some points from there. So here's y. If I were to plug in, I'm going to plug in 2, because that's a good one, because 2 minus 2 is 0. 0 times negative 1, 0. 3 to the 0 power 1. And then 1 minus 4, right? 1 minus 4 is negative 3. So I've got a point to negative 3. I'm going to then plot, let's plot 1. So if I plot 1, 1 minus 2 is negative 1. Negative 1 times negative 1 is 1. 3 to the 1 power is 3. And then 3 minus 4 is negative 1. So it looks like I've got 1 negative 1, and then I've got 2 negative 3 so far. And so is that enough? You're actually going to be asked to plot 5 points, maybe 3 to 5 points. That's what I do expect. And so I would plot a point over here, like 5. So 5 minus 2 is 3. 3 to the negative third power is going to be 1 over 3 to the third. So that's 1 over 27. And that minus 4, not nice. I'd have to get a common denominator. But that's going to bring me down here. And so thinking about, 1/27 minus 4 is negative 3 and 26/27, right? And so that's the kind of graph that you're looking for. So just keep in mind, this is my graph, drop it down. And so you just have those values moving to the right, dropping it down, etc. Now, here's a log graph. And so when we're looking at our log graph here, I would say that you would start with base 10. And so you want to say this is 10, this is y. So 10 to the y power is equal to x plus 1. And then if I'm going to be plugging in y, so I know realistically, right, our parent function, if you think about it, our parent function, which is y is equal to log of x, that's our parent function. We know that's 10 to the y power. We already know our 2 points, right? Our 2 points for this would be 1, 0 and 10, 1. We did that in the previous example. So we had 1, 0, and then we had 10, 1. And we knew that our graph, our parent graph, is going to look something like this for log. This is y equals log of x. Now, the 2 ways you graph that is you take the parent function and then you move with your transformations. And all the transformations are for this problem is to move to the left, horizontal, left, 1. So that's all I had to do. So instead of saying 1, 0, I'm at 0, 0. Instead of saying at 10, 1, I'm at 9, 1. And so my asymptote, which was here, that moves with me when that moves my graph, that moves with me with my graph, okay? So that's got to go with me. So that my new asymptote is over here at x equals negative 1. That's my new asymptote because it should have been at 0. The original one was at x equals 0. And then each of these points moves so that my new graph would come through here. My new graph would come through there and then go through 9, 1. And that's just moving it over to the left. That's it. But you can plot points, right? So you can say, well, this is x equals 10 to the y value minus 1. And then I'm just going to plot values. So like I would say, for x and y, now remember, if y's up here, right, if y's up there, you're plotting for y, so 0 and 1. So 10 to the 0 power is 1. 1 minus 1 is 0, and that's my 0, 0. 10 to the 1 power is 10, and 10 minus 1 is 9, and so that's my 9, 1. So you can plot points, or you can graph the parent function and then shift it left and right. For this problem, though, this is e to the x plus 3, also exponential, right? So remember, what's the parent function? The parent function is y equals e to the x power. And if you plot values for x and y, you get 0 and, x is up here, so I'm going to plot 0 and 1. E to the 0 power is 1, and e to the 1 power is 2.718. And so just graphing the parent function, which is 0, 1, and 1, 2.718, this being exponential, right? Okay, this is my exponential graph. All we're doing with this is we are plus 3, which means I'm going 3 to the left. This is my horizontal shift. If I had a number outside here, like plus 4, this would be a vertical shift. But I don't have that, so there's no vertical shift. It's just move it to the left 3 units. That's all it's saying. So I can just physically go 1, 2, 3, new point, and then 1, 2, 3, new point. And now my new graph looks like this, okay? Or I can actually plot points, and you guys can plot values. You know, you're gonna plot, if you plot 0, you would just make points. You would say, okay, I'm gonna plot 0, 1, 2, whatever. And then as I plot 0, 0 plus 3 is now e to the 3rd power. I'm gonna use my calculator and go, well, that's 0, whatever that value is, right? And then I would plot 1. 1 plus 3 is 4. E to the 4th power. Use my calculator. And so that's what I would do until I got my actual graph, which is the shift to the left 3 units. For this problem here, this is a log base 2. And so the graph, this is actually saying y equals log base 2 of x minus 3. So again, you have the option. How do you want to solve this, right? What's the parent function? The parent function is 2 to the y power is equal to x minus 3. Parent function is a base 2. So if I was just looking at a base 2, right, the base 2, I could flip these, right, my x and my y, and I could say, well, my base function is 2 to the x power equals y. This we would do later. And then I would plot these values for 0 and 1 for x and y. So 2 to the 0 power is 1. 2 to the 1 power is 2. And then graphing this, I would have 0, 1, and then I would have 1, 2, right, which is exponential. But this being log, that's the inverse. So I would have to take these points and flip them. And so instead of this being 0, 1, my first point is 1, 0. And instead of this being 1, 2, it's actually 2, 1. And so this base 2 log equation actually starts off like this. All right. And so that would be my parent function of just 2 to the y power equals x. Now, the minus 3 actually takes my graph to the right and goes x equals 2 to the y plus 3. That moves it left and right. This means horizontal shift. Horizontal shift. And so that means I'm going to go 3 points to the right. So this is going to be 1, 2, 3 here. And this will be 1, 2, 3 here. So my new graph is going to look like this, okay? And so that's just taking that original graph and moving it. So you have got to decide, you know, how you want to actually graph. Do you want to graph by just plotting points in here, which you totally can, but you just have to remember when you do that, if y is up here, your y values are first. If you take the inverse first, right, you went 2 to the y equals x, and then you took the inverse, which is just switching x and y, and then getting those 2 points and then going back so that you can plot the inverse, right, which is that reflection here across the y equals x axis. Then you can do that. And all that's going to yield is just another way of you doing this problem. And again, we've got this graph here, which is our log base 2, which is slightly different than the log base 10. And you know, because for log base 10, your 2 points are 1, 0 and 10, 1. But if it's a log base 2, your 2 points are 1, 0 and 2, 1. You see how that so log base 3 would be 1, 0 and 3, 1. Likewise, a log base 5 would be 1, 0. You're still always going to have 1, 0. And then 5, 1. Okay, so that's all you're doing. For this problem here, I'm going to rewrite this simply because I've got y equals, I'm going to say negative ln of x, and then see that's a plus 1, so I'm going to go plus 1. So I just want to rewrite that because I do like the vertical shifts, which that is right there. I like those last. So this is a vertical shift. And so with this, I'm going to take my ln of x, because remember what's ln of x? Ln of x is y equals, right, log base e of x. And remember, that's e to the y power equals x. Now, I'm not doing the inverse, which I could do if I wanted to, but I'm just going to graph this just based on having y up here, y, and then I'm going to do y first, 0, 1. So this would be plugging in 0, I'm going to get e to the 0 power is 1, and plugging in 1, I'm going to get e to the 1 power, which is 2.718. And so I would graph 1, 0, make this a little bit bigger, okay, and let's make that bigger. And then I'm going to move, I think I'm going to try to move this down. Hold on a second. And so when I'm doing this, what I'm getting is I've got 1, 0, and then I've got 2, okay, 1, 2.7, it's almost there, up 1, right? And so this is my ln of x graph right here. That's what that is. That's ln of x right there. And so what you do with that value right there, that ln of x, this negative sign is it's a reflection across the x-axis. So what that does is it takes this here, it stays there because that's on the x-axis, and then this value is now down here. And this point is, what is that point? 2.718, comma, instead of positive 1, it's negative 1. And so this graph is now doing this, like this, okay? I still have my asymptote right here at x equals 0, still there. Now, all this is doing is shifting up 1. This is my vertical shift. So my graph is going to go up 1. So I'm going to take both of my points and I'm going to move them up. So instead of this being 1, 0, now it's going to be here, which is 1, 1. And instead of this point being 2.718 negative 1, it's now right here at 2.718 comma 0. And so this being my final graph here, it's going to look like this. That's the blue graph like that. Okay, and you are going to have points for this. And this is in purple, the way that looks like that. But you're going to have to graph your points. Make sure that you have a minimum of 2 to 3 points. I would say no more than 5 for sure. So for this problem, this is a exponential function again. And so this one is going to be coming, because it's 1/4, right? This graph, I would plot, I know that this is going to come down, instead of going up like this, right? It's going to come down like that. So let's just plot the parent function, which is y equals 1/4 to the x power. And so again, I'm going to plot 0 and 1 for x. And notice I didn't take the inverse, because I'm going to try to do this without finding the inverse, okay? So we're going to say x, y. I'm going to plug in 0 and 1, and plug in more values if you want. 0, anything to the 0 power is 1, and 1/4 to the 1 power is 1/4. So my 2 points are 0, 1. Make this bigger again, okay? So my 2 points are 0, 1 here, and then 1, 1/4. And so that should give you a heads up. Oh, it's not exponential going up, it's a regression, it's going down. So this is going to be a decay, and this is going to go this way, like that, okay? And so based on those 2 points, right, now, number 1, you always do the reflection across the x-axis first, which is what that is. So that is a reflection across the x-axis. That's what that does. So then that means our points, instead of being 0, 1, are now 0, negative 1. And this point, which was 1, 1/4, is now going to be 1, negative 1/4. So that's 1, comma, negative 1/4. And so that graph, which is a reflection, looks like this, right? And now that's going to look like that, okay? Now, check, we did that. This part right here is our horizontal shift, left and right. So this is saying go right 1. So this point here, which is at 0, negative 1, is now here, which is at 1, -1. And this point, which is at 1, -4, 1/4, I'm going to the right one, is now going to be at 2, -1/4. And so now this graph is looking like this. Okay, and that's going to be, I don't know where that's shifting to that value here because we didn't find that point, but that's okay. Now, lastly, we're going to take those 2 points and we're going to move those up. So I'm going to take this graph and shift it up 2 points. So everything gets moved up. And so all you're doing is you're taking your actual values and moving everything up too. Now, note to self. Yes, you can absolutely plot points for X and Y based on this original equation. Okay, absolutely. Let's do 1 or 2. I would try 1. I would plug in 1 first because 1 minus 1 is 0. 1/4 to the 0 power is 1, but -1. And then I have -1 plus 2, which is 1. So I already know this point here is 1, 1. And is that easier? I don't know. I mean, like, you got to figure out which one, what works best for you. I would also plug in 2. If I plugged in 2, 2 minus 1 is 1. So I have 1/4 to the 1 power is still 1. And so I've got -1/4 to the 1 power is 1. And then add 2. So I know that that value, -1/4 plus 2, is 1 3/4. So 1 3/4. So over 2, up 1 3/4. So, I mean, you've got to figure out, you know, how is this working for you as far as a graph? This is my new graph here, the blue, which is in this graph here, down here is red. Check your answers on Desmos. Absolutely. This is going to help you just be a better, you know, grapher, etc. This is e to the x plus 1 minus 3. So again, yes, you have a calculator. You absolutely can graph points. You can plot points. And I would plug in 0. I would plug in 1. Because if I plotted 0 for this graph, right, x, y, 0 plus 1 is 1, e to the 1 power. So if I plugged in 0, I get e, which is 2.718, and then minus 3. So 2.718 minus 3, right? And these are just giving me my final graphs. 2.718 minus 3 gives me what? -0.282. So at 0, I'm at -0.282. So this is 1 point. So 0, -2.82. So this is one of my final values, right? I also would plug in -1, definitely, because -1 plus 1 is 0. E to the 0 power is 1, and then 1 minus 3 is -2. So I've got at -1, I'm at -2. So this should give you like an idea what your graph actually looks like. But that being said, you still need a graph. I mean, you need at least more than that many points. So another way of doing that, right, is other than that is to take the parent function, which is y is equal to e to the x power, and saying, okay, here's x, here's y, plug in your 2 points, 0 and 1. So e to the 0 is 1, e to the 1 is 2.718. And so if I were to do this, I would get 0, 1, and then I would get 1, 2.718. So I know that this graph is being exponential, is doing this. All right. Taking that graph, see this plus 1 here? All that's doing for me is it's moving my graph 1 unit to the left, but then it's dropping it down 3 points. And it looks like I have one of these points is actually incorrect. That's got to be down. That's not true, this point right here. And so this would go like that. And so you've got to be able to say, okay, how am I going to draw my graph? How is it going to, what's going to give me the best way to do my graph? I personally like to graph the parent graph because here we had 0, -2.2, and I think this value should be down farther. This isn't the right point. But as we drop it down like that, you've got to be able to, when you're plotting your points, you've got to be able to verify, hey, this is a shift, this being a horizontal shift up on top. If this is the value here, if it's exponential, that's my horizontal shift. And if it's a +1, I'm going to the left one. this value here, either plus or minus, that's my vertical shift. And so that's either going to take my graph and move it up or down. Okay. These two problems here, just trying a few more. You know, if I graph the parent function, which as you get better at this, you're going to see, okay, well, log base 10 of x, right? Log base 10 of x, do you need to graph 10 to the x power first, right? And then find the inverse? Or do you now know that for a log equation, for this one specifically, log base 10, that you're going to start off with 1, 0 and 10, 1. So I know right now this graph looks like this, right? So based on that, see this minus sign? That is a reflection across the x-axis. So now that value, instead of going up, is going to look like this, okay? Reflecting across the x-axis. And then this plus 1, what that does is it takes my graph and it shifts it to the left 1 unit. Now, where are my points at? So you can plot these points, or you can just move them from the parent function. And so now this 1, 0 is now, when I move it to the left, is at 0, 0. And this value here, which is, this value here, which is 10, negative 1, when I move it to the left, is now going to be 9, negative 1. And so these 2 points now, this looks like this. All right, so you've got to decide, because if you're going to actually plot points, then you're going to take this value here, this 10, right? And you're going to go across the x, you're going to go 10 to the y power, and then you're going to plug in values for x. And since also you do have a calculator, you can also plot points directly into x, right? You can say, you could just type this in your calculator. Well, what is log of 0 plus 1, right? Or you can plug in different points for x using your calculator like this, just plotting the points like that. For this problem down here, this is 2 base to cross the equal sign, so 2 to the y power, right? So this is a log base 2. So for me, I would graph this log base 2, because we know our 2 points, right? We already talked about this. Our 2 points being 1, 0 and 2, 1. So we already know, let me move this up. We already know that this graph right here has a point at 1, 0. If it's base 2, it's 2, 1. If it's base 10, it's 10, 1. If it's base 5, it's 5, 1, etc. So I know this graph does this like this already. Now, what are all my transformations doing? Number 1, that's my horizontal shift. That's going to take my horizontal shift, that's going to take my graph and move it to the right 3 units. So these points are going to go 1, 2, 3 here, and 1, 2, 3 here. And so now this graph is going to do this. All right. And then this plus 2 is my vertical shift. And what that's going to do is take these 2 points and go up 3 here, up 3. And so my final graph did this. Now, don't forget that your asymptote moves with you. All right. So if my asymptote originally was right here at x equals 0, when I moved to the right 3, my asymptote came with me. Yeah. Okay. So that means that asymptote, when we moved, why isn't that doing that? Anyway, it just moves to the right with you. Okay, so that's what you have to remember, that the asymptote moves with you. Okay, this is an ln of x. Just again, this is another way of graphing. You have to decide, what's going to work best for you. For an ln of graph, you know that the parent function, which is ln of x, and you should know by now that the graph of ln of x is going to go this way. And you're going to go through 1, 0, and you're going to go through 1, 2.718, 1. And so you've got to know you've got those 2 points. So once I have those 2 points, which is 2.718, 1, what's happening with this. This is a reflection across the x-axis if the value, if the negative sign is in front. So reflecting that across the x-axis, now it looks like this. And then the +2 takes the graph and shifts it up 2 units. Now, again, you could graph it this way and say, well, you have e to the x power, and then you're going to, that's your exponential function, right? And then you're going to reflect it and then move it. So you got to decide how that's going to work for you, and how to get to that actual graph. And this is in different steps. This is my y equals x because this was a reflection across the y-axis. This is a different way of doing it than I actually did here. You have to decide, like I said, do you want to find the inverse and then plot the points, or do you want to graph it with the parent function, or do you just want to plot points? So that's what you're thinking. This one right here, use transformation. So remember e to the x power. All right, e to the x power equals y is my parent function. And again, if I were to plot values for x and y, x is up here as the exponent, so I'm plotting in for x, so 0, 1. E to the 0 power is 1, and e to the 1 power is 2.718. And so as I'm graphing this, and I know this is like here, if I'm graphing 0, 1, and then over 1 up 2.718, this being my exponential function, right? This negative sign reflects across the x-axis, so now my graph does this. And this value here takes my graph and actually picks it up and moves it 3 units to the right. And so these are the different ways that, and this is what I was just saying with this being moving to the right. You've got to decide, how do you want to do this? Do you want to plot points, or do you just want to use the parent function and move it as you go? So that's it for graphing logs. And you've got a couple of Desmos assignments and then 2 worksheets to practice. Hope this helped you make sure that right now that you work on graphing worksheet number 1. And if you get ahead and you want to work ahead, you can start graphing worksheet number 2 and both of the Desmos assignments. So thanks so much for watching.